All right, so before we start on this, which will go on page 81 when we're done, we're going to watch a little video that kind of previews what we are doing.
Hey Brain Stuff, I'm Jonathan Strickland. So you've probably seen geographic coordinates like these before, maybe on a GPS device or maybe scrawled in a mysterious note you found in the glove box of a rental car. But if you never knew exactly what they meant, fear not. It's actually pretty simple, and we are here to make it all clear. When you see a set of geographic coordinates looking like this, or like this, you're reading latitude and longitude. Latitude represents north-south location, and longitude represents east-west location, usually listed in that order. By combining them, you can pinpoint any spot on the surface of the Earth. These coordinates aren't expressed in units of distance, but in degrees. Why? Because the Earth is a sphere. Imagine a line running from the equator to the center of the Earth, and then another line running from the center of the Earth to the North or South Pole. These two lines make a 90-degree angle. All latitudes in each hemisphere can be represented by drawing a third line somewhere between them. So the equator would have 0 degrees latitude, and the North Pole would have 90 degrees north latitude, and a location halfway between the North Pole and the equator would lie at 45 degrees north. Same thing for the southern hemisphere, except you'd call it degrees south. For more precision, each degree of the Earth's surface is divided evenly into 60 minutes, and each minute is divided into 60 seconds. If you need to get even more specific, you can just add decimals to your seconds. Alternately, you can write the whole coordinate in decimal notation. To do this, you have to convert minutes and seconds, which are base 60, into our regular base 10 counting system by dividing each unit by 60 and then summing them up. The results sometimes look counterintuitive, but if you're skeptical, you can pause the video and check out the math. Lines of longitude, also called meridians, run north-south and are used to measure position along the east-west axis. While the lines of latitude run parallel to each other, meridians converge at the poles and spread farthest apart at the equator, like the segments of an orange. Longitude is also measured in degrees, but its 0-degree line is known as the prime meridian, and it runs from the North Pole to the South Pole through Greenwich, England. So, if the prime meridian is 0 degrees, the opposite side of the Earth is 180 degrees, and lines in between are expressed as degrees east or degrees west, between 0 and 180. Since the lines of latitude are parallel, each degree covers about the same distance the world over, roughly 111 kilometers. But because meridians converge at the poles, the distance covered in each degree of longitude varies hugely depending on your latitude. At 20 degrees north, which is about the latitude of Cuba and Hawaii, 1 degree of longitude is approximately 104 kilometers. At 80 degrees north, the latitude of Svalbard and northern Greenland, it's only about 19 kilometers. So, let's say I wanted to go dig up a stash of hot loot from some coordinates I found written in a mysterious note. Even without looking at a map, we can start to make a guess where this would be. Since it's 43 degrees north, it's almost halfway between the equator and the North Pole, again halfway being 45 degrees. And since it's 89 degrees west, it's almost halfway west between the prime meridian and the opposite side of the globe, halfway being half of 180 degrees or 90 degrees. Based on this alone, you can guess it's probably somewhere in North America. But if we use a map or a digital tool like Google Earth, we can zoom in and see these coordinates lead us to the U.S. National Mustard Museum in Middleton, Wisconsin? Huh. Well, what's the weirdest landmark you've ever found on Google Earth? Paste the coordinates in the comments so everybody can check it out. If you like.
Yes, I know. One of the oddest things, can smoking a scorpion get you high? Why is that on the end of an educational video? Have no idea, but no, I haven't watched it.
How those ID cards work.
I don't even know. Okay, so besides the scorpion thing, did you learn anything? Or was there anything new that you didn't know? Okay, well, just like time is base 60. You got 60 minutes in an hour. Well, how do you convert 1.2 hours into minutes? Now you take the 0.2, because you have 0.2 or 2/10 of an hour, and you multiply 0.2 by 60, and that tells you how many minutes it is. Just a conversion thing. And that's what we're about to do here. So some angles have decimal degrees, for example, 26.5. Angles with decimals can be expressed using degrees, minutes, seconds form. What's wrong with my pen there? Which the degrees are subdivided into minutes and seconds. So 1 degree is 60 minutes. 1 minute is 60 seconds. So 1 degree is how many seconds? 60 squared, good, which is 3,600. So you convert this into degrees, minutes, seconds, just like you would convert anything into hours, minutes, and seconds. The symbols are degrees. There's your little degree symbol. That's not a new thing. Minute is a little apostrophe. Second is a little quote. So what else do we use for the apostrophe and the quotes? What else does this denote? What? Feet and inches. Good. Feet and inches. So feet and inches, which this is not, but that's just also the little notation there. Okay, so here's how we would convert this. We take 31.875, right? So we know it's going to be 31 degrees. And then you have 0.875 of a degree, right? So you take the 0.875 part of that, and you multiply it by 60 to figure out how many minutes that is. And whose signature is this? The secretary? And when you do that, what do we end up with? That's why you have a calculator.
We end up with 105,
which is 52.5. Well, if you hit the SD key, you'll know exactly. So that means I have 52.5 minutes, right? So it's 52, but we don't put the 0.5, 52 minutes. You take the 0.5, you're going to multiply that by 60 to figure out how many seconds. And if you try and use the calculator, I'm going to come snatch it from your hand and smack you over the head with it. 30. Thank you. Okay. Oh, yeah. All right, so that 31.875 degrees is the same as 31 degrees, 52 minutes, 30 seconds. Okay? Well, it has nothing to do with time. It's just a different way to break up degrees. Like parts of an hour are minutes and seconds. Parts of a degree are also minutes and seconds. Totally unrelated. Totally unrelated from time, yeah.
So if 30 would have had a decimal, we would put 30 and then...
Yeah, so like if I'd have gotten 30.2, then it would be 30.2 minutes. Yes, I'm sorry, 30.2 seconds. Yes, absolutely. The only thing that'll have the decimal on it is the seconds. Yes. Okay. All right, so let's do number 1. Okay, so we're going to take number 1, and it's 15.48 degrees. So I know it's going to be 15 degrees. Then I'm going to take 0.48, and I'm going to multiply it by 60. When I do that, what do I get? 28.8, which means that's 28 minutes. And then I take that 0.8, multiply it by 60 to see how many seconds. And that gives me what? 48. And so it's 48 seconds. Okay? Easy enough? Because you only want the full minute. So this means 28.8 minutes, but I don't want a decimal minute. So I take the 28 minutes and then convert that 0.8 into how many seconds. Does that make sense?
Is this just like a life skill, or are we actually going to be using it?
Oh, we're totally going to be using this, yeah. Oh, no. Not just a life skill. No correlation to time at all, no. Exactly. And now I understand the question somebody was trying to ask me third period. And, okay, I get that now. I need to, yeah. No, it has no correlation at all to time. Why they couldn't come up with something other than to call it minutes and seconds, I don't know. But I don't have the answer to that one. But no, it has absolutely nothing to do with time. Okay? Nothing at all. Okay? Yeah, no. No, it has nothing to do with time. I'm glad I cleared that up. Okay, so we're not doing all of these, of course, but we're going to do number 2. So 150 degrees, and then 0.2 times 60. What does that gives me? 12. So then this is just 12 minutes. There are no seconds. That can happen, okay? Because it's exactly 12 minutes. No, you don't put 0 seconds. It's just like, that's it. Just like if it was exactly 150 degrees, you just put 150 degrees. Okay. All right, so you work on number 6. Number 6. Yeah. All right. Yeah, then you just leave the decimal.
Wait, so this, the first one's not the one thing, the decimal, right?
Yes.
That one cannot have a decimal, but
The seconds can, yes. We're not going to break it down to milliseconds or anything like that. It's like yeah. So the only thing that can have the decimal on it is the seconds. I don't even know. I don't know the answer to that one either.
is it always just going to be like to one decimal point? Or
But if you do it to 3, you always do it to 3 unless you're told otherwise. You probably shouldn't get many crazy ones, but yeah. All right, so let's flip it over. Wait, are there any questions though? Good. Okay. So now let's look at converting the other way. Most of the time, what we're going to be concerned with doing is converting this way because we're going to be given the information in degrees, minutes, seconds, and we're going to have to convert it to decimals so we can actually use it. All right. So we have 73 degrees, 9 minutes, and 50 seconds. So I know it's going to be 73 degrees in the end, right? So 73 point something. So I'm going to take that 9, and instead of multiplying it by 60, I'm going to divide it by 60. Okay. And when I do that, what do I get? 0.15. Okay. And then I'm going to take that 50, and I'm not dividing it by 60, because on the front, technically the seconds we multiplied by 60 twice, right? Because we multiplied, then we had to multiply again. So I'm going to have to divide and then divide again, which means I'm really dividing by what? 3,600, yeah. 3,600. So I do 50 divided by 3,600, and I get 0.0138 repeating, right? So what I'm going to add here is 73 plus 0.15 plus the 0.0138 repeating. So when you get to that point, you have that 0.0138 repeating in your calculator. You can either store it, or if you haven't done anything else with it, you just add 0.15 to it. Why did I put 76? I don't know. It's a very good question. Oh, Lord have mercy. I just wanted to see if y'all are paying attention. Good job. Okay. I don't know where I got 76 from. 73. How's that? That's better. Makes more sense, right? So then I lost my number. So I take the 0.0138 repeating, add 0.15 and 73 to it, and I get 73.164 degrees. And that's my answer. Okay? And then that's a decimal that I can actually use to calculate whatever I need to calculate. We good? So yes, it's kind of a life skill, but, you know, I don't know how often you really have to do it in your life, but you might need to. I don't know. I mean, yeah. How are you going to know how many minutes and seconds you're from? All right, so let's look at number 10. 35 degrees, 8 minutes. So this, 35, oh my gosh, 315 degrees. So it's 315 point, and then I'm going to take this 8, and I'm going to do what with it? Divide it by 60. And so that gives me 0.133 repeating, right? So we always do everything to 3 decimal places unless we're told otherwise. And that is it. Okay? So if there's no seconds, it makes it a whole lot easier. All right, so then let's do number 12. Now on number 12, I intended for this to be a negative 121, and I forgot to fix it on here again. So we're going to make that a negative 121. We're doing that because I want you to see it doesn't change what you do at all. You don't start subtracting things. You're still just adding them all up and pretending like it was just like all the other problems. So we're going to have a negative 121 point something. So I take the 4, I divide it by 60. I'm going to take the 45, and I'm going to divide it by 3,600. If I do not get nice, pretty, even decimals, then I probably want to store things. So that 4 divided by 60 will give me 0.066 repeating. I would highly suggest that you store that number so it just makes it easier on you in a minute. So second recall X, boom, it's stored. Just like all the other times we've stored it. Then 45 divided by 3,600 gives me 0.079. Yeah. Oh, no, I'm sorry. No, it doesn't. I'm making that up. Making stuff up again. I don't know what's wrong with me. 0.0125. And then you can just add to that the X that you stored. and you should get 0.079. That's where that comes from. If you round at the wrong time, you will get the wrong answer in the end. Okay? Everybody good? Okay. All right, so then I want you to do, oh, and it's negative, but notice how I did the same stuff and added them all up? No subtracting there, okay? So don't try and make that more difficult. Then you do number 13. $13. Okay, that's what I got. Do you agree with me? Do you have any questions? Awesome. Yeah, it's pretty easy. Even though this is something we are going to use, we actually don't even use it until next semester, but it goes with all this angle stuff, so I decided I wanted to go ahead and get it out the way. That way, when we do need to use it, it's something you've already seen. It won't be that big of a deal. Okay? So that is it.